going back to what I talked about with the fact that really probably for our purposes, rover tracks are sufficient as a road. And this is the Apollo 17 landing site, and these are the Apollo 17 rover tracks. And of course, they don't really go anywhere, they just kind of loop around, but they're still, 50 years later, viewable from space, perfectly adequate as in terms of a track that you can follow. And as I said, I was not able to find anything like the planetary address framework. The only thing I can find in the literature is technology that's used to pave a road, like lasers, microwaves, 3D printers. So I'm not only claiming the first roads in space, but I'm also claiming the definition of something called space roadbotics, which nobody has talked about up until now. This was my first customer validation. This is the traverses for the Apollo 15 mission. This was the first rover ever up on the moon. And if you note, the longest traverse is a straight line, whereas the other two are loops. And the reason for that is because when they were down there at Spur Crater, Dave Scott and Jim Irwin were over the horizon from the lunar module. So they were disoriented. They didn't know where they were. They just looked around and all they saw was this vast expanse. And so when they rediscovered their rover tracks, they just followed the rover tracks all the way back. And then there's a transcript of sort of a post-mission discussion, and Dave Scott basically says, yes, it's true, there's some good horizon features, and sure, it's true that we have good nav systems on the rover, but you can't beat the old Hansel and Gretel trick. So this was the first time I started to think, you know, they might actually prefer just to be able to do something that feels like Earth, where they're following some kind of trail back to the lunar module or wherever they're trying to go. These are examples of lunar rovers that are manned. The one you see over here on the left, or on the right, is the Apollo lunar rover, and the one you see on the left is an artist rendition for Artemis, for the Artemis mission, where this is actually going to be a dual mode rover, where you're going to have astronauts driving it, and then when there's no astronauts up there, they're going to be able to use that in autonomous mode. And that design actually goes all the way back to Apollo. So it appears that what NASA is doing is kind of picking up where Apollo left off and doing some of the things that they had wanted to do 50 years ago but couldn't. So this idea of a roadbot is based on the idea that we really need to optimize these autonomous rovers for speed. If we're going to do this, we're really going to do this, you know, you're going to be making a lot of roads. And if you have the current autonomous rovers, which are kind of stop and go and collect soil and do this, basically designed for science missions, it's going to take you forever. So I found this great company called GMV that's actually optimizing their autonomous rover for speed, and it goes up about 2 miles per hour. And obviously they're not doing this to make roads, but certainly you could take some of the same ideas and do something that was indeed designed to make rover tracks and roads.